Subscribe to our YouTube channel, Joy Learning TV.
Lesson. My name has always been Opoku Nyako, and I'm your junior high school science facilitator. Today is a different ball game altogether. Different ball game altogether in the sense that we'll be doing a bit of tricky things here, a bit of teaching here, a bit of being interactive, and as well as perform an experiment that I'm doubt whether you know about. We'll do it and then we'll see about that. So till we do that, let's see what we have today. Look at these people and the way they are so much engrossed in their tag of war. And why do you think that nobody is moving? Is it because they all have the same force? Is it because they all have the same energy? Or is it because they are all tired and they've all relaxed? We will see as we go on. By the end of the lesson, you and you out there should be able to understand and explain the concept of force. Identify the types of forces in specific activities. Outline 4 applications of surface tension. And definitely we'll also discuss what is surface tension. List 3 ways of reducing surface tension. Perform an experiment to demonstrate the concept of surface tension. So that's all we have to do today. Under force and pressure. We'll take this as the first half because we have to understand these details, and then when we come back again for this same topic, we'll be doing a bit of calculations under pressure and then force. In simple terms, a force is said to be a pull or push of an object. So it means that if I have a pencil here and then I throw it, it is believed that a force has been applied on the pencil. That is how come the pencil has acted based on the force applied. If the pencil is left on the table, do you think the pencil will move? Obviously no, because no force has been applied. But as soon as it's been moved a bit, or it's been touched a bit, then it means that it will move, because the force that I've applied on it is what will cause the pencil to also act. The pull or push is resulting from the object's interaction with another object or another. And here we're talking about the pencil and myself. When the pencil was left on the table, there wasn't any movement. But when I did touch the pencil, it moved. Reason being that I have caused the pencil to move. So there's been an interaction between me and the pencil, causing the pencil to move. There's always a force whenever there is an interaction between 2 objects. So one man or one guy is in the car and the other is pushing the car. This tells you that the one in the car is trying hard, but the ignition key of the car doesn't want to work. As we say, car and spark it. So force needs to be applied to the car so that the car can now move, and then the ignition can be turned on. A force can also be the capacity to do work or cause physical change. A force can also be the capacity to do work or cause physical change. So if I have a knife in hand and I want to cut something, then definitely a force has been applied. All right. I have my small pair of scissors that I call kinky, and I have my paper. How do I create or make a cut with this scissors? All that I need is to cut the paper or the tissue paper with the scissors. How will that happen? I need to apply force with my body onto the pair of scissors to also do the work. And as I do that, then definitely the force has been applied to be able to do the cutting. Now, from your screens, you would see somebody doing something and another guy is also assisting him. This clearly shows that that guy is trying to do a bit of press up, and the one guiding him is also telling him how low or high he should go. A force is that which changes the state of rest or motion of a body. A force will always change the state of rest or motion of a body. So if something is just at rest, if there's no force applied, there wouldn't be any movement. Why will a bicycle rider sit on the bicycle if the bicycle is not moving? How will the bicycle move when the rider is on the bicycle? There's only one way by which the bicycle would move. It means that the rider would have to apply the needed force through his legs or her legs to be able to paddle the bicycle in order for the bicycle to accelerate or be in motion. Force is the product of mass and acceleration due to gravity. Now we have so many kinds of forces. So we say that gravitational force will always pull items that are up onto its body. That is why when you throw something up, what you've thrown doesn't actually get lost in air, but then all just don't vanish. As you throw it up, due to the force of gravity, it pulls it back onto the earth's surface, and that item that has been thrown high up now comes back onto the earth's surface. Mathematically, force, or the formula for finding force, is mass times acceleration due to gravity. Let's go to the types of force that we have. Types of force. Now, there are so many activities being performed by these different people. So we have one who is pulling or pushing a trolley. There's another one who is also in the air flying. There's another who is also skiing. And then one is also in a parachute. With all these, certain different kinds of forces are being exhibited here. When you come to the other side, we have two people that are pulling a rope. We also have another item being picked up by. Then we also have a magnet that will also help to attract certain magnetic materials like the nails and the pins and all that. And then there's a spring in a package that has been tied to a toy. So we have frictional force being applied to the man that is skiing. We have gravitational force pulling the one that is flying to the ground or to the earth's surface. We have applied force helping the man to either push or pull the trolley. The one in the parachute is also dragging the whole thing to come down by using the drag force. Buoyant force will also help the load to be lifted up. Tensional force will exist when two people are pulling two things to the opposite sides. Magnetic force will also help by bringing magnetic materials very close to a magnet. And the spring force will also allow the toy to go up and down in the pack. Force of gravity. An apple is now moving to the earth's surface due to force of gravity. Gravity is a force which pulls objects down toward the ground. When objects fall to the ground, gravity causes them to accelerate. So when they get to the ground, then they move because of the same force. So there's no way a mango will fall from a mango tree and then get stuck onto the soil just like that. Unless probably it falls into a mud or it falls into a container. And as soon as it hits the floor, it must be in motion or it must accelerate. Acceleration is the change in velocity, and velocity in turn is a measure of the speed and the direction of motion. So as the speed of something changes, then it means that that thing has accelerated. It's building up or building on so much speed to the point that it is moving faster than it used to be. Air resistance, another force. A force that acts in opposite direction on an object when it travels through air is known as air resistance force. So it's at the opposite directions, and then it's all acting on a particular item. Air resistance force. We have a man who is trying to come down with a parachute. Falling objects have two main forces that act on it. The force of gravity pulling them towards earth and air resistance acting in the other direction and slowing their fall. The size of these forces change as the object falls until the object reaches a constant speed called terminal velocity. So whenever you hear terminal velocity is where that item has now gotten to a point where it is neither or it is not going faster as it's used to be. Force of friction or frictional force. Now, the boy is also pushing an object. So we have the frictional force being shown on the base of the object and then the surface or the top of the floor. As two opposing surfaces slide or come together, then the force of friction is being exhibited or showed here. Friction is the force exerted by the surface of an object when another object moves against it. So when I bring two of my hands together and I rub my hands vigorously together, it means that with time, my palms will be warm, and it shows that these opposing two surfaces are being brought together vigorously, and the end point is the generation of heat. Friction occurs in the direction opposite to the motion, and because of this, it is a force that affects motion of objects. So whenever things are being moved or whenever things are in motion, then definitely frictional force is applied. Elastic force. So I have a rubber band and then I'm trying to open it up. As I open it up, then elastic force is at play. This is the force that allows some materials to return to their original shape after being stretched or compressed. It is true that the more you actually try to open up a rubber band, the lesser or the more it actually increases in size, because you have opened it so much to the point that it cannot come back to its original position. And this is because of the elastic force happening in there that helps it to be able to open and then come back whenever that force of opening is applied. Elasticity is a feature of the body that allows it to return to its original form or size after external forces have been withdrawn. So if you take off external forces, then the feature of elasticity is being at play. Magnetic force. What is magnetic force? Why is it that a magnet is able to pull towards itself a nail, a safety pin, a paper clipper, and then the rest, pins, nails? Now all these ones are able to just get attracted to the magnet because of the force of magnetism that works by pulling objects that are magnetic materials towards the body of the magnet. And like I always say, every magnet is very strong at the ends. We have two ends of a magnet, which are the south pole and the north pole. So every magnet has that strength of magnetism at the poles. So there's no way I'll have a magnet in hand like this and then I'm drawing or I'm bringing a pair of scissors very close to the ends or to the middle of the center of the magnet, and then expect this metal blade or metal scissor to get stuck at the middle of the magnet. It wouldn't happen. As I try to bring it very close to the center, the poles will also want to pull it towards its end. So if it's a north pole here, the north pole will exert that force that will pull the scissor to its end, because that is where that strength or force of magnetism is always exerted or felt. Pins and nails are referred to as magnetic materials, and so the force of magnetism would obviously pull the magnetic materials to itself. This is a force that makes opposite ends of a magnet to be attracted to each other. The virtue of the law of magnetism, the same poles of a magnet are also able to repel and then or unable to attract. Electrostatic force. Electrostatic force. Have you ever used a comb or rubbed a comb in your hair severally? Before you do that, just try to get pieces of papers on the table. Now, do that vigorously. Or it can be a comb, it can be a pen or a pencil. Just go forth on and off like that severally in your hair or on your hair for like say 2 minutes. Right after that, bring it very close to the pieces of papers and see what will happen. It's just gaining, or it has gained a charge, which is called electrical charge. So as you move the comb, the pencil, or the pen through your hair in that constant motion to and fro for say a minute or two, you allow that pencil, the pen, or the comb to obtain or gain what is called electrical energy. And when these items are brought very close to the piece of papers, it then picks them up to a height. So as you pick them up to a height, as you move up your hand, then the force or electrical energy declines, and then you see the papers falling off. That is what is called electrostatic force. This is the force of attraction or repulsion of objects due to their electric charge. So we have the comb here, and the comb has been wrapped severally in the hair, and then the comb has been brought very close to a piece of papers, and you see the papers getting stuck on the comb. Surface tension. Now, why is it that mosquitoes and other insects are able to walk on the surface of water? Why is it that water bodies like pond allow these insects to walk on them? Water bodies like rivers that are always on the run do not allow these animals or these insects to walk on them. It's simple. This brings us to the subtopic called surface tension. Surface tension is the property of liquids which makes their surfaces behave as if they were a stretched elastic skin. There's no skin on top of the water, but the fact that the water is always stagnant brings up the property of surface tension. So with this, these insects can actually walk on top of the water. It can be, say, a housefly, it can be a mosquito, or any other thing. They walk majestically on top of the water, and you will be just thinking about how are they able to walk, because to them there is a stretched skin on top of it. Now let me also say this. Have you also realized that when you put a bucket of water there and then probably you sweep around it, you see particles of dirt or dust being or settling on top of the water? Why do you see that particle of dirt settling on the water? The water is no more in motion, it's not moving. The bucket of water has been kept there for some time, so it is believed that the water has now settled. Surface tension has been built on the surface of the water, and because you swept and then you are seeing dust on top of the water, it is that layer of the stretched skin that is believed to exist that is giving you that impression that there is dust on top of that stretched skin. That's how come you are seeing the dust on top of the water. So this is a clear picture of an insect that is gorgeously walking on the surface of the water. The main reason why the river wouldn't allow any of these insects to walk majestically on top of it is simple. It's always in motion. A pond is stuck. It's stuck up. It doesn't move. So these surface tension built up severely. But when a river, even with a river, okay, every river meanders. I know Auntie Anita will be saying that. What are you saying? My dear, I learned a bit of geography when I was in senior high school. So when it's meandering, or it's just moving in its course, whereby probably it's curving. When you say it's meandering, it means it's curving. Okay? No river or no water body moves on a straight line like that. It doesn't happen. So what happens is that as it meanders, the whole velocity or acceleration rate of the water now goes down. It doesn't mean that no insect can settle. They can't settle. They now just settle on it and then they go away, because if you're not careful, the water will take them away. That property is what is all about surface tension. In areas where there is stagnant water, it can as well be seen on rivers that run slowly. That is very, very slow. If the water is just running so faster, my dear, no insect would want to risk or ruin its life, so it will not even dare. The effect of surface tension allows objects which could otherwise sink in water or liquids to stay on top of the liquid or water. So that property is what will warrant any other thing that will, intentionally or normally go down or sink to come or settle on top of the water. Surface tension varies in liquids. The effect of surface tension in water can be reduced adding soap or detergent. Now, you know what? This is just the first half of this. And when I come into your homes again, we will talk about the second half of this show, and then we will talk about the experiment I was talking about. Till I meet you, my dear watchers or viewers, I say goodbye and have a nice day.
Channel Joy Learning TV.